You know that specific kind of betrayal you feel when you check your weather app and it just looks you dead in the eye, metaphorically speaking, and says it's partly cloudy with a 0% chance of rain?
Oh, yeah. The absolute confidence of it.
Right. You feel good.
Yeah.
You head out for a run, or maybe you're a site manager scheduling a massive concrete pour.
Mm-hmm.
And then 20 minutes later, you're standing in a torrential downpour. You're soaked to the bone.
And the app still says it's sunny.
Yes. It still insists it is a beautiful day. It feels entirely personal, like the universe is just pulling a prank on you.
It's the universal gaslighting of modern life, honestly. Everyone experiences it.
But looking at the research we have today for this deep dive, it turns out it's not personal at all. It is structural.
Very structural.
And that is exactly where we're starting. We're looking at a stack of documents centered around a project challenge proposal that basically argues our entire approach to weather data is broken.
It really is broken. I mean, we tend to think of weather as this big, smooth, regional blanket that just covers a whole city evenly. But the reality and the science in this proposal tells us weather is incredibly local. It's jagged. It is specific to micro-locations.
And that gap between regional and local is where all those ruined concrete pours and wet socks happen.
Exactly.
So the sources we are looking at today propose a really fascinating solution to that jaggedness. We are talking about the deployment of mini weather stations.
But specifically ones powered by the Favorite Insight framework.
Which is a bit of a mouthful, I admit.
It is a mouthful, but the mission behind it is actually pretty incredible.
Right. It's about taking all this raw, messy environmental data and transforming it into what the proposal calls operational intelligence.
Yes. How do we stop just guessing about the weather and actually start making decisions that save money and, frankly, keep people safe?
Moving from, oh, it might rain somewhere in the metro area today to, it's going to rain on this specific construction crane in exactly 4 minutes.
That's the exact shift. It's all about precision.
So let's strip this down for you. The proposal starts by identifying the core problem, and they really don't pull any punches here.
No, they don't.
They point out that localized weather variability is increasing. We're talking flash floods, sudden heat waves, haze.
And the data absolutely backs that up. We are seeing a lot more volatility in the environment.
But the core argument isn't just that the weather is getting wilder, it's that our current infrastructure is just blind to it.
That's the real danger. They identify 5 specific environmental gaps, intelligence gaps, that organizations are facing right now.
I want to walk through these 5 gaps because I think most people, myself included, just assume the weather data on our phones is the absolute truth.
Right.
So gap 1 is the lack of hyperlocal data.
Think about how your phone actually gets its weather. It's usually pulling from the nearest airport or maybe a major government meteorological station.
Which could be 20 miles away.
Exactly. And in a city or in geographically diverse terrain, 20 miles is a completely different world.
You have the urban heat island effect, right?
Yes, concrete trapping heat. Or you have skyscrapers that channel wind into tunnels.
Wow.
So gap 1 is simply that the sensor is too far away to be useful. You could have a violent storm cell hovering directly over your work site while the airport reading 20 miles away is totally calm.
So you're basically flying blind because you're relying on a regional average, not your local reality.
Which leads directly into the second gap.
Delayed detection.
Right. This is the time lag issue. Standard reporting intervals for those big regional stations might be every hour.
And an hour is a lifetime in a storm.
In a flash flood scenario or a sudden squall line, water levels rise critically in minutes. If you're waiting for the hourly update to tell you there is a problem,
your basement is already underwater.
Precisely. Or your construction site is totally washed out. You don't want to know about the flood after it happens. That's just history.
You want to know when the rain intensity spikes before the accumulation becomes a disaster?
You need real-time data, not a retrospective.
And that brings us to the third gap, which is limited early warning. The proposal makes a really sharp distinction here between knowing it's raining and knowing the operational risk.
That is a crucial nuance in the source material.
Yeah, it really stood out to me.
Saying it's raining is just data. It's just raw numbers. But saying the rain is heavy enough to destabilize the soil on the north slope of the excavation site, that is intelligence.
And most current systems just stop at the data.
They do. They don't give you the warning linked to the specific risk of your operation. They leave the interpretation up to you.
Which is dangerous, or at least wildly inefficient.
Absolutely.
Okay, Gap 4 seems a bit more technical, but I bet it's a huge headache for anyone in facility management. It's fragmented data.
This is the classic silo problem. You see this everywhere in the industry. You've got a thermometer from 1990 on one wall, a new rain gauge you bought last year on another system.
And maybe a separate air quality monitor you just installed.
Right. And none of them talk to each other. They're entirely in silos. You can't see the correlation between high heat and poor air quality because the data lives on two different screens.
Or even on paper clipboards.
Seriously, yes.
Yeah.
Paper clipboards.
So you never get the full picture. Which leads to the final gap, Gap 5, the absence of predictive insights.
This is the big one for the strategists listening. If you don't have a history of hyperlocal data, if you haven't been recording exactly what happens at your specific site for the last year.
You can't predict what's going to happen tomorrow.
Exactly. You are always reactive. You're fixing things after they break instead of preparing for the break. You need that historical baseline to train any kind of predictive model.
The stakes here seem pretty high. The proposal mentions safety risks, operational disruptions, massive maintenance costs. We aren't just talking about a ruined barbecue here.
Think about the cost of being wrong on a commercial scale. If a construction site stops work because they think it might be too windy based on a regional forecast, they lose thousands of dollars an hour in idle labor and equipment.
But if they keep the cranes running and a microburst actually hits,
then you are looking at catastrophic equipment failure, potential loss of life, massive legal liability. Being precise isn't a luxury anymore. It is a strict requirement for doing business safely.
So that is the gloomy reality of operating in a fog of regional averages. Let's pivot and talk about the solution.
Let's do it.
The proposal breaks this down into hardware and software. Let's look at the hardware first, the mini weather station.
And the word mini is key here because it's what allows for dense, widespread deployment.
Now, I will be honest. When I hear weather station, I picture a little plastic thermometer nailed to a fence post, but reading the specs here, this is a lot more robust.
Just a little bit more, yeah. It is a comprehensive sensor suite. And what's really interesting is what they specifically chose to measure. Take wind, for example.
Right.
It's not just measuring speed and direction. They're specifically monitoring gust intensity.
Why the specific focus on gusts?
Because average wind speed is deceptive. A steady 20-mile-per-hour wind is totally manageable for most structures.
Okay.
But a sudden 60-mile-per-hour gust, that is what snaps a crane cable or knocks a drone out of the sky. For operational safety, the variance, the gust, is actually more important than the average.
You have to catch the spikes.
Exactly. It's the surprise that gets you.
That makes perfect sense. Then the proposal lists rainfall. They measure intensity, accumulation, and duration.
Again, look at that intensity metric. That is your flash flood indicator. It tells you the exact rate of rainfall.
Right, because drains can only handle so much at once.
Urban drainage systems are designed to handle a certain flow, let's say 50 millimeters per hour. If the intensity exceeds that flow, you know the drains are going to back up before the street actually floods.
It gives you a head start.
It gives you a 15-minute window to put up sandbags or divert traffic. It literally turns a disaster into a managed event.
The one that really stood out to me personally was the air quality monitoring. They are tracking PM 2.5, PM 10, carbon monoxide, nitrogen dioxide, ozone. This feels like it goes way beyond just weather.
It does. It moves directly into environmental health and safety. PM 2.5 are those tiny microscopic particles that get deep into your lungs, usually from vehicle exhaust, industrial smoke, or forest fires.
The haze season stuff.
Exactly. If you're running a school or a university campus or an open pit mine, you have a duty of care.
Yeah.
If a factory 2 miles away has a leak or the wind shifts during a forest fire, the air quality at your specific site can drop to dangerous levels in minutes.
You can't wait for the citywide report to come out on the evening news.
No, you need to know if your air is toxic right now.
And then they also have the core indicators: temperature, humidity, air pressure, UV index.
Which sound basic, but when you combine them computationally, you get things like a heat stress index.
Oh, that's smart.
For agriculture or construction workers, knowing the exact heat stress level allows you to mandate water breaks legally and safely. It prevents heat stroke. It's simple data, but it's applied for human safety.
So we have this mini station collecting all this incredible data: wind, rain, poison gas, heat stress. But as we've discussed on previous deep dives, having a spreadsheet full of numbers isn't the same as having answers.
A spreadsheet full of numbers is usually a nightmare if you don't know what you're looking at.
Exactly. More data usually just means more confusion. Which brings us to part 2, and honestly, the meat of this proposal: the favorite insight framework.
They call this the brain.
Right. The hardware is just the nerves. Favorite is the cortex. The proposal breaks this down into a 7-layer system architecture.
This is where the magic happens.
I really want to walk through this architecture because I think it demystifies how the Internet of Things actually works in the wild. It starts with layer 1, data acquisition.
This is the connection layer. The sensors have to send their data somewhere, and the proposal emphasizes extreme flexibility here. They use protocols like LoRaWAN, NB-IoT, LTE, or even standard Wi-Fi.
For the non-engineers listening, why do we need so many different acronyms just to send data? Why not just use Wi-Fi for everything?
It's all about the environment and power consumption. If you're in a city building, Wi-Fi or cellular LTE works fine.
Sure.
But imagine you are monitoring a massive palm oil plantation in the middle of nowhere, or a remote water reservoir. You don't have Wi-Fi out there.
Right.
That's where LoRaWAN comes in. It's a low-power, long-range radio signal. It can travel miles and miles on a tiny battery. This layer basically ensures that no matter where the station is, deep jungle or city center, the data gets out securely.
Okay, so the data jumps off the sensor. Layers 2 and 3 are device management and data storage.
Think of this as the gatekeeper in the library.
Okay.
Favorite registers the device to ensure it's secure. You definitely don't want someone hacking your weather station to fake a storm and disrupt your operations.
That would be a mess.
A huge mess. Then it ingests that constant stream of real-time data. It organizes it for time series analysis, which basically just means storing it in a way that makes looking at the history instant. It's a perfect chronological record of reality.
But layer 4, I circled this one 3 times in my notes. The rule engine. The source material calls this the absolute game changer.
It is. If you take one thing away from the technical side of this deep dive, make it the rule engine. This is what separates passive monitoring from active operational intelligence.
Break that down for us. What is the practical difference?
Passive monitoring is a dashboard you have to look at. It requires human attention. Active intelligence is a system that taps you on the shoulder.
Oh, I see.
The rule engine watches the data stream for you, 24/7. You set the logic. You tell it if wind gust is greater than 40 kilometers per hour and the crane is active, then trigger an alert.
And that alert isn't just a blinking red light on a server somewhere in a closet.
No. The proposal lists automated emails, API triggers to other software systems, and very conveniently, Telegram.
I love the Telegram integration. It feels so modern and direct.
It's incredibly practical. Think about a site foreman. He isn't sitting in an air-conditioned office staring at a monitor. He's walking the site, wearing a hard hat, dealing with 100 problems.
Right.
Suddenly, his phone buzzes in his pocket. He looks down and sees a Telegram message. Critical wind alert, gusts exceeding 40 kilometers per hour. Halt crane operations immediately.
And he just blows the whistle.
Exactly. That is immediate action based on hyperlocal data. There's no interpretation needed. No, should we or shouldn't we? The rule was broken, the alert was sent, the action is taken.
That is so powerful. It entirely removes the hesitation.
It removes human latency and the cognitive load. You don't have to worry about the weather because the system is worrying for you.
Moving up the stack, we have layers 5 and 6, analytics and visualization.
This is the dashboard layer. But because of the historical time series data we stored in layer 3, now we can do real trend analysis. We can see risk heat maps.
How does a heat map help in practice?
Well, a facility manager can look at this and say, hey, why does our air quality always dip into the yellow zone on Tuesday afternoons? And maybe they discover a massive delivery truck idles near the intake vent every Tuesday.
Oh.
You can't solve that operational problem if you can't see the historical pattern.
And finally, layer 7, integration via open APIs.
This is all about playing nice with others. A smart city command center doesn't want to log into 10 different proprietary apps for 10 different types of sensors.
They want it all in one place.
They have one massive screen controlling traffic, police, fire, EMS. Layer 7 allows the favorite data to flow seamlessly into that central platform. It becomes part of the city's central nervous system.
So we've built the machine. We have the hardware sensors, the favorite brain, the automated Telegram alerts. I really want to ground this now. What does this actually look like in the real world on a random Tuesday morning?
Right. Let's look at the applications.
The proposal outlines 3 key scenarios. Let's start with scenario A, construction and industry.
We touched on this with the crane example, but let's go a bit deeper into compliance. Currently, weather compliance on job sites is often just a manual checkbox.
Yeah.
Someone physically writes down weather was fine today in a paper logbook at the end of the shift.
Which I'm sure is always 100% accurate and never just filled out in a rush before heading home.
I'm sure it's flawless. But with this system, the compliance reporting is fully automated. The system records the wind speed every single second. If an accident does happen, you have an immutable forensic record.
At 2 p.m., wind was well within operational limits.
Exactly. It protects the company from liability. But more importantly, the predictive alerts actively prevent the accident in the first place. You aren't guessing if the storm is coming. The system tells you it's 10 minutes away because it's actively tracking the intensity trends upwind.
Scenario B is agriculture. Precision farming. This feels like a massive economic opportunity.
It's huge for resource management. Imagine you irrigate your crops on a fixed schedule, say every morning at 8 a.m.
Okay.
And then it rains an inch at 9 a.m. What have you just done?
You've wasted a ton of water.
You've wasted huge amounts of water, electricity for the irrigation pumps, and you've potentially drowned the roots or washed all your expensive fertilizer away.
You're fighting the weather instead of working with it.
Exactly. But with hyperlocal rain and soil data, the automated irrigation system, triggered by that Layer 7 API, checks the conditions first. It sees the thermal moisture is already high, or it sees a rain cell incoming, and the pumps stay off.
So it optimizes yield while cutting overhead costs. It's farming with data.
Pure efficiency.
And finally, Scenario C, smart cities and townships. This really feels like where municipal governance is heading.
This is all about public health, particularly the haze issue we see in so many regions. Imagine a city council right now. They usually issue a blanket warning. Air quality is bad in the city today.
But maybe it's only bad in the industrial district down south, and the northern suburbs are perfectly fine.
Or maybe the wind is funneling all the particulate matter into one specific valley neighborhood.
So the current method causes completely unnecessary panic in some places, and not enough urgency in the places that actually need it.
Right. With a grid of these mini weather stations, the council has situational awareness down to the neighborhood level. They can send automated alerts specifically to nursing homes, hospitals, or kindergartens in the affected zone.
Close your windows now. PM 2.5 levels are spiking.
Exactly. It allows for surgical interventions rather than blunt, citywide panic announcements.
It actually protects the vulnerable populations.
It really does. It completely changes the role of the municipal government from just reporting the news to actively protecting citizens in real time.
So looking at the big picture here, the proposal wraps up with the strategic value. Why should a business or a government invest in this? Because it isn't cheap to deploy enterprise hardware across a whole city or a massive industrial site.
It's an investment, for sure.
Yeah.
But the first pillar they mention is climate resilience.
Right.
We cannot ignore the reality that the environment is becoming more hostile. We simply have more energy in the atmosphere right now. If the weather is getting wilder, our eyes and ears need to get sharper. You cannot run a 21st century operation with 20th century weather data.
It's really about survival, in a way, just adapting to the new normal.
It is. And then there is operational continuity.
Yeah.
Which sounds like dry business jargon, but it just means staying open.
Not shutting down unnecessarily.
Exactly. If you can predict the micro-weather, you can schedule your maintenance during the verified safe windows. You aren't constantly surprised by the environment anymore.
Right.
You stop losing massive amounts of money to acts of God because you actually saw them coming and you adjusted your plan beforehand.
And they also mentioned living labs. This is the university research angle, right?
Yes. If you blanket a large university campus with these sensors, you create a data set that environmental researchers dream of.
Oh, I bet.
You can train new AI models to predict micro-weather patterns. So it's not just using the technology to stay dry, it's actively advancing the science of AI and meteorology. It turns the entire campus into a smart city sandbox.
It feels like we are finally closing the loop on weather. For most of human history, weather was just something that happened to us. We were entirely passive. We looked up, saw dark clouds, and just hoped for the best.
That is the fundamental paradigm shift here. We are moving from, oh, look, it's raining, to it is raining at a rate of 20 millimeters per hour. The local drainage will overflow in exactly 15 minutes, so the system is diverting traffic right now.
That is the difference between data and intelligence.
Absolutely. The real value isn't in the sensor on the pole. The sensor is just a piece of plastic and silicon.
Right.
The value is in the decision-making architecture behind it. The favorite framework that turns that electronic signal into a concrete, life-saving decision.
We've covered a lot of ground today. We went from the sheer annoyance of wet socks and ruined runs all the way to a sophisticated network of IoT sensors, cloud ingestion, and automated telegram bots saving construction sites from disaster.
It is a journey from total ignorance to hyper-awareness.
So as we wrap up this deep dive into hyperlocal data and the Favorite framework, I'm really curious, what is the one thing sticking with you from all these sources?
I've been mulling over a very specific thought while reading through this proposal. We often talk about technology purely as a convenience, making things faster or easier or cheaper.
Yeah.
But this feels fundamentally different.
How so?
Well, we now clearly have the capacity to make our cities and our industrial sites sentient to the environment. We can know, down to the street corner, exactly when the air is toxic or the wind is deadly.
Sentient cities. I really like that image, like the city itself has a nervous system that reacts.
Exactly. But it leads to a much harder question for leaders. If the technology exists to know these risks in real time, at what point does failing to use hyperlocal data stop being just a lack of technology update and start becoming actual negligence?
Wow, that is heavy.
Think about it. If a crane falls because of a sudden gust, you easily could have detected with a sensor that costs a tiny fraction of the crane's value, but you just didn't install it. Is that an unavoidable accident anymore? Or is it a choice?
When the tools to see the danger exist, ignorance becomes a choice.
Exactly. And I think we are crossing that threshold right now.
That is definitely something for everyone to think about. Next time you check your weather app and it lies to you about the rain, just remember the solution is out there. It just needs to be deployed.
Thanks for joining us on this deep dive.
Stay safe out there.